Now let's get into kind of the graphing portion of this lesson. And example 3 is just very clearly graph y equals 2 to the x power, and then we're going to answer these questions over here in this box. So let's use our calculator. We're going to put 2 to the x power. I'm going to go zoom 6 for a standard, since that's what this graph here is. And here is my graph. Now I can see that that is increasing by looking at that. And now what I want to do is get some ordered pairs. So I'm going to go second table. And let's see what we can fit on here. So I'm going to start right here with -2. And I'm going to go down to 3, 8. So here is my table. We're going -2, -1, 0, 1, 2, 3. And we have 0.25. That is a fraction, is 1/4. I'm going to put 1/4. Then 1/2, 1, 2, 4, and 8. Okay, so now I'm going to plot those ordered pairs, and I'm not going to connect them yet. I want to talk about them before I connect them. So here are my ordered pairs. Now let's talk about what's happening here. We can look at the calculator, and I'll show you in the calculator, but let's just kind of look at this logically from the values that we have. As my x is getting bigger, so as I am moving along my x values to the right, what are happening to these numbers here? We're going from 1/4 to 1/2 to 1 to 2 to 4 to 8. All of those values are doubling. 1/4 times 2 is 1/2. 1/2 times 2 is 1, times 2 is 2, times 2 is 4, times 2 is 8. Why? Because we have a base of 2. So that base of 2 tells me everything's basically doubling there. Okay, so as I go along these x values then, as to the left, right, as these are going the opposite direction, these are all getting cut in half. So we'll have half of 1/4 is 1/8. Then we'll have 1/16, 1/32, 1/64, 1/128. As you can see, when you go back on these numbers, these are getting closer and closer to 0. But if I keep halving my number, I am technically never going to get to 0. I'm going to get really, really close, but I am never actually going to get to 0. So what we have going along this x-axis here is we have a horizontal asymptote at y equals 0. Now it looks like my asymptote's a little above. If anything, I probably should have made that a little bit below. It's hard to do with that ruler though. But what I want to do when I connect these points is the big thing. I want to make sure I don't cross that x-axis. Okay, so it's getting closer and closer to 0, but never approaching it because of that horizontal asymptote. And so we barely talk about asymptotes. We only talk about asymptotes really with exponentials, and then eventually we're going to get to logarithmic functions and graphs in this module. But essentially what an asymptote is it's what this graph is approaching but never touching. So when I go over my domain is from left to right. So we go arrow to arrow. So my domain is all real numbers, or, oh, that's so bad, or negative infinity. To infinity. Then my range, as I go from the bottom to the top, the first thing I hit is that asymptote. So that asymptote is at y equals 0. And because that asymptote means this graph is never going to touch it and never going to cross it, this 0 is not included. So we have a parentheses here to infinity. Now, where are my x-intercepts at? Well, if this is having a horizontal asymptote on the x-axis, then that means we have none. And where is it crossing on this y-axis? It's crossing right here at 0, 1. Now, before we go on to the bottom of this page, let's just kind of talk about graphs that are kind of similar to this. So let me share a different screen here. Okay, so here is Desmos here, and I already have it clicked on 2 to the x power. So that's what we've already graphed right here. And you can see it's crossing right here at 0, 1, and you have that horizontal asymptote. So what happens when I have 3 to the x power? How is it going to compare to this graph here? And you can see here now in blue, it's rising much quicker because now instead of everything doubling, how it does with 2 to the x, now everything is tripling. So it starts here at 1, then it's going to jump up here to 3, and then it's going to go to 9. Maybe, but you see, but and then it's going to go to 27, and then 81, and so now everything is tripling, so it's going to climb much faster. So then when you go x to the 4th, everything's quadrupling, so it's going to increase even more, even faster. X to the 5th, or 9, 5 to the x, 6 to the x, even faster, 7 to the x, even faster than that. Now, all of these graphs have 2 things, well, I guess maybe even 3 things in common. First, they're all increasing, and they're all increasing because this base is greater than 1. So we'll put that on our sheet when I get done with Desmos. Another thing they all have in common is that they all have an y-intercept at 0, 1. Because anything to the 0 power equals 1. So 2 to the 0 is 1, 3 to the 0 is 1, 4 to the 0 is 1, and so on. And then they all have that same horizontal asymptote right there at y equals 0. So it's really just kind of a matter of how quickly is this going up. Now, in the first video, not the intro video, but the one after that, we talked about how the base cannot equal 1, and I said I was going to talk to you about that. And here we are talking about it. If I have x to the 1st power, that is just a horizontal line, because if you do 1 squared, that's 1. 1 cubed, 1. 1 to the 10th is 1. 1 to the 100th. It doesn't matter how many times you multiply 1 by itself, it is always going to be 1 right here. So my base cannot equal 1. It's not an exponential because that's just a horizontal line. If you want to kind of still have an increasing graph, but make it increase more shallow, you need your base to be closer to 1. So if we have maybe a 1.5 to the x power, you can see that becomes a little bit more shallow of an increase. 1.25 to the x, even more shallow. And if you do something like 1.1, I think it's really, really shallow right there of an increase. Okay, so that's what all of our graphs look like when I have a base that is greater than 1. Oops, shared the wrong thing. Let's try this. So anytime we are increasing when my base is greater than 1. Now let's just go ahead and let's stop. I'm going to stop the video there. In the next video, we'll go over our transformations.